Hi guys, welcome to my channel Science for All by PK. Today we are going to talk about a chapter electricity which is in 10th standard. And I will not go in too much of detail but still cover good concepts so you will be able to understand. This is going to be useful if you are preparing for exam, or if you didn't get enough time to prepare in detail, or just before exam, or you are already completed your 10th standard and you are in 11th and 12th and you want to do quick revision of electricity in 30-40 minutes. Let's start. So this chapter starts with current. When I say current, it means electric current. What is electric current? Rate of flow of charge. Rate of flow of charge is called electric current. Whenever I am saying rate, that means I am trying to find something for unit quantity. Rate means for unit number, unit quantity. In this case, charge is flowing in given time. So I am trying to find how much charge is flowing in 1 second, and that is called current. Let's write. What is electric current? Rate of flow of electric charge. Suppose charge Q coulomb is flowing in t seconds. In that case, what will be the rate of flow of charge? It is going to be Q divided by T, and that is what we will call electric current. So whenever I am writing current, that means electric current. Electric current is denoted by I, capital I, charge is by Q, and time is small t. So what will be the unit? Unit will be coulomb per second, right? And there is another name, or ampere. This is the capital. Wherever we have capital letters, that means these units name have come on the name of somebody. Say there was a scientist named by ampere or coulombs, right? But there was nobody by name second, so this is a small letter. Okay. So what is electric current? Electric current is charge divided by time. How much charge flowing in given time, and the unit is ampere. Next topic is electric potential. What is electric potential? Electric potential is measured in volt. So whenever you buy a battery, you see that it is 5 volts, 10 volts, 12 volts, whatever it is. That means it is given electric potential difference. We will come to electric potential difference, but we are talking about electric potential. So what is electric potential? Electric potential is work done in moving unit charge. Say this is infinity and you have a unit charge, say for example 1 coulomb. You are moving one charge from infinity to a point. Say this is point A. So in moving unit charge from infinity to a point, say A, whatever work we have done, that is called electric potential at that point. Where? At this point. So I have done some work bringing from infinity to this point, and this is called electric potential, right? Suppose I have done W work in bringing charge Q. In bringing charge Q, work done, this is work done, and this is charge. So how much work is done in bringing unit charge? That is going to be W by Q, and this is called electric potential. This is called electric potential. Now next topic is electric potential difference. What is electric potential difference? Whenever we are saying difference, that has to be happen between two different things. Say for example, I have a point A and then I have another point B. So now what I am doing, I am measuring electric potential here and electric potential here and finding the difference between these 2 points. In other words, I can say work done in moving unit charge from point A to point B, if it is unit charge, and work done, whatever work done, is called electric potential between these 2 points. Let me repeat again. Work done in moving unit charge from point A to point B is called electric potential between these 2 points, right? So this is the definition of, or the formula of electric potential, right? What is the unit of work done? It is joule, and the unit of charge is coulomb, joule per coulomb, and the another name for this is, as I said earlier, is volt. This is also name of, after the name of somebody, so this is capital V. Next important topic is Ohm's law. What is Ohm's law? Till now we have studied what is electric current and then electric potential difference. Now Ohm's law gives relationship between those two quantity. Ohm's law gives relationship between those two quantity, electric potential difference and current, right? So it says, Ohm's law says, at a given temperature, that means temperature is constant, temperature is not changing. In case temperature is changing, then Ohm's law is not valid. So at a given temperature, that means temperature is constant. So at given temperature in a circuit, electric potential difference is directly proportional to current or electric current flowing in it. That means if potential difference is V and current which is flowing in the circuit is I. So let me make a circuit. This is a symbol of resistor. Say this is R and this is a battery, plus minus. So and the current flowing is I. Now Ohm's law says this voltage and this current will be proportional to each other. V is directly proportional to I, and we know when we replace this proportional symbol with equal sign, we have to add one constant. In this case we are adding a constant R, right? Normally it is written as V equal to IR. Okay, this is Ohm's law. Now what is this R? This is called resistance. This is called resistance, and the unit of resistance is ohms. So you can write this symbol ohms or OHM, right? So what is Ohm's law? Ohm's law says at given temperature, electric potential difference is directly proportional to the current flowing in the circuit, and we can write this way, right? This is very important relation. When we connect a battery to a conductor, current flows in it, and this conductor provides some resistance, some opposition of this current flow. How much opposition is provided by this conductor is called resistance, which was given by R, right? If R is high, then current will be less. Now next topic is resistivity. If I have a conductor and the current flowing in this is I, voltage is V, and resistance of this conductor is R, and cross section, say if I am seeing from this side, cross section area is A and length is L. Length is L. Current flowing I, V is the voltage applied across this, R is the resistance given, and then L is the length of this conductor. In that case, this resistance provided by this conductor is directly proportional to length of the conductor. Directly proportional to the length of the conductor. If longer length, then higher the resistance, and inversely proportional to the cross section area. Inversely proportional to the cross section area. That means if cross section is more, resistance will be less. Current will be flowing easily in a thicker conductor. We know that when we have same quantity one side, then we can combine this relationship and write by multiplying this, the quantity on the right side is R proportional to L by A. R proportional to L by A. Again, like earlier, when we will replace this proportionality sign by equal sign, then we have to add a constant, and in this case it is rho. So this will become R equal to rho L by A. R equal to rho L by A. Rho is called resistivity. There is a difference between resistance and resistivity. So what are the major difference? That also I will be explaining soon. Now let's find the unit of resistivity. So rho equal to R A by L. So unit of rho or resistivity, unit of resistivity equal to unit of R into unit of area meter square divided by unit of length, that is meter, and we get ohm meter. So what is the unit of resistivity? It is ohm meter, right? Now what is the difference between resistance and resistivity? Resistance depends upon the shape and size of the conductor, that means length and cross section of the conductor, while resistivity is the property of the material. That means if I have a wire made of copper, whatever dimension it is, resistivity will be fixed. But when I am changing length or diameter, its resistance will be changing, not the resistivity. This is the major difference. Another difference is, if in case it is coming in exam, is unit of resistance is ohm and resistivity is ohm meter. We have seen the opposition provided by a conductor is called resistance, and it is denoted by symbol like this, right? This is the value. Now if I have multiple conductors, different conductors, then they may have different value of resistance. Now there are multiple ways I can connect it. Broadly I can divide into two categories, and then we can have different combinations. So one of them is called series connection, another one is called parallel connection. Let us see what happens. So suppose I have these three resistance and I have connected, say R1, R2, R3. I have connected them one after another like a chain. This is called series connection. This is called series connection. And another possible connection is where I am connecting all of them in parallel. So these points are common. One side all the points I have taken connected together, then another terminal also is connected together, and say this is R1, R2 and R3. Now suppose if I connect a battery here, V, and current flowing is I. In a series connection, current will go like this and then come back, same current will come back. We are assuming there is no loss or no resistance given by these connecting wires, right? Same will be the case here. Now if I connect this voltage here, now I am trying to find what is the equivalent resistance or total resistance offered by this connection or series connection. Now what will be the current flowing here? Because the same current is going here, also it is going to be I1, I, here also I, here also I, okay? But the voltage drop or the voltage across this resistance will be different, for each one will be different and given by Ohm's law. So this will be given by, say this voltage is V1, it will be given IR1. This will be, say suppose voltage drop is V2, IR2, I is same, right? V3 equal to IR3. So here total current, if I am saying total current and total voltage potential difference, what is the relationship? Relationship is V equal to IR. In this case V is this, I is this, and R is equivalent resistance. Because it is in series, let me say it is RS, and this is my equation 1. Now from these three different voltages I can write V1, I, R1, V2, I, R2, V3, I, R3, second, third and fourth. Now we know that this voltage is getting distributed among these three resistance. That means there is no other loss in the circuit. So sum of these voltages is going to be equal to this voltage. So I can say V equal to V1 plus V2 plus V3, and V I can say from here IRS IR1 plus IR2 plus IR3, and I can take I common, that means R1 plus R2 plus R3, I get cancelled, RS equal to R1 plus R2 plus R3. So this is the relationship, right? It is easy to drive. So remember, in this case current remains same in the circuit, but voltage across the resistance is changing. Now what is happening in the parallel circuit or parallel connection, say suppose, and this side is plus minus and current flowing is I. And one more thing, when we say plus, current always flow from this direction, from plus to minus, and electrons flows in opposite direction, right? Electron flows in opposite direction. If current is flowing clockwise in the circuit, electrons are flowing anti-clockwise, right? Now what is happening, this current is seeing three different resistance and three different opposition. So where opposition is more, current will be less, where opposition is less, current will go more, right? It is like connecting big pipe to three different pipe. Wherever it finds difficulty, water or liquid will not flow easily, right? So say suppose this is I1, I2 and I3. So because same current is getting divided into three, this I is getting divided into three currents, so I can write I equal to I1 plus I2 plus I3, right? Now same this current I1, I2, I3 again getting combined, so it will again become I. Now what is happening, because we are saying there is no loss here, so this voltage at this point and this voltage potential difference at this point is going to be same. So that means potential difference across R1, R2, R3 is going to be same. So potential difference is same, but current is different. So I can write, suppose, I can write here I1 equal to V, because voltage potential difference is same or voltage is same, V divided by R1, I2 equal to V divided by R2, and I3 equal to V divided by R3. Now again similar way, I'll put this value here, and okay, let me see if the equivalent resistance of this circuit is RP. I'm saying RP because it's in parallel, and so in that case it is going to be V equal to IRP or I equal to V divided by RP. Now in this equation, let me put the value from these equations. So I equal to, so here I equal to V by RP, V by RP, I1 from here V by R1, V by R2 and V by R3. V I will take common, V divided by RP, V is taken common, 1 by R1 plus 1 by R2 plus 1 by R3. V get cancelled, so 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. Please note this point, this is not R, this is R1 by RP. So if you are using this formula, whatever value you get, then you have to take the inverse of that to find the value of resistance in parallel. Now let me take some questions. This is 5 ohm, this is 7 ohm. What is the total resistance? Say suppose total is RS, then RS equal to R1 plus R2 equal to 12 ohms. Simple. Now if I have 6 ohm and then say 8 ohms, and this point is A and B, I need to find total resistance or equivalent resistance between point A and B. Then say equivalent resistance is Rp, because in parallel 1 by 6 plus 1 by 8. I will take LCM, that is 24. 6 4s are 24, 8 3s are 24, so it is 7 by 24. Remember, it is 1 by Rp. So Rp equal to, I will take the inverse 24 by 7 ohms. This is the value of this circuit. Say in exam question can be like this. Let me make it neatly. Now, what is the total distance between, and this is say 4, between point A and B. Now, these two resistors are in parallel. So let me first solve this. So let me first find this. What is this? Say suppose this is Rp. So 1 by Rp, 1 by 3 plus 1 by 6. So LCM 6. This is 2 plus 1, 3 by 6, or 1 by 2. This is again 1 by Rp. So Rp is going to be 2 ohms. This is 2 ohms, right? Now circuit will become like this. This is point A, 4 ohms, and then in place of this I have already calculated this is 2 ohm. 2 ohm. So in that case, now these two are in series. So total is 4 plus 2 equal to 6 ohm, right? So this can be solved like this. Now one more thing. When two resistors, say 6 ohm and 6 ohms are connected in parallel, then what will be the total resistance? 1 by Rp equal to 1 by 6 plus 1 by 6 equal to 2 by 6 equal to 1 by 3, Rp equal to 3. Suppose this number is changed and I am taking 10 ohms and 10 ohms. What is happening? 1 by Rp equal to 1 by 10 plus 1 by 10 equal to 2 by 10 equal to 1 by 5, and Rp equal to 5. What is happening? Okay, before we conclude, let me take one more example. So if this is 12 ohm, this is 12 ohm, and this is also 12 ohm, right? All these are ohms. So in this case, 1 by Rp equal to 1 by 12 plus 1 by 12 plus 1 by 12 equal to 3 by 12, 1 by 4. Rp equal to 4. Now, when I am taking two similar resistors, it is becoming half. When I am taking three similar resistors, it is becoming 1/3. If I am taking n resistors, then it will become nth time of that. Say for example, if n resistors are connected here, n, then equivalent resistance of this will be Rp equal to 12 divided by n. Right? It is easy to remember and easy to solve. Now next topic is heating effect of electric current. Heating effect of electric current. Now it's very simple. What is happening when electrons are flowing in the conductor? It's not a hollow pipe. There are a lot of molecules, and these electrons are struggling and they are rubbing to each other, and you can see when you rub your hands together there is some heat generated, and same thing is happening. These electrons is when it is running there is a friction, and because of that heat is getting generated. Now if resistance is more, heat is more, and resistance is less, heat is less. So now how to say this? What is the heating effect of electric current? When current flows in a circuit or in a conductor, when current flows in a conductor, its temperature goes up. This phenomena or this effect is called heating effect of electric current. I will repeat. When electric current flows in a electric conductor, its temperature goes up, and this phenomena is called heating effect of the electric current. Now suppose we have one conductor. This is the conductor. We have applied voltage V across this conductor and current flowing is I, and because of this voltage the charge which is flowing in this is Q, right? Charge flowing is Q. Say suppose this charge is flowing in time t and total work done, because we are moving this Q coulomb charge from here to this point, so we are doing some work. So I have written different, so I am not writing here in detail, it is easy to write, I am writing only the quantities. So voltage V is applied across this conductor, because of this current is flowing I, and charge which is flowing because of this electric potential difference is Q in time t, and the total work done in moving this electric charge is W. From electric potential difference we know that what is electric potential difference? V equal to work done in moving unit charge. So total work done is W and total charge is Q. So this is W by Q is work done in moving unit charge, and that is equal to electric potential, right? So work done W is V into Q. Work done equal to V into Q. Now we know one more thing. Say suppose this is equation 1. The first definition which we have done of electric current, rate of flow of charge is called electric current. Repeat, rate of flow of electric charge is called electric current. That means I equal to Q divided by T, or from here Q equal to I multiplied or I times T. This is equation 2. Now if I put this relationship here, then W equal to V into I into T. This is very important relation. What is the relationship between work and energy? These are two sides of same coin. Work and energy, they have even the same unit, which is joule, right? Now work can be converted to energy, energy can be converted to work. Say for example, if I am lifting this pen from one point to another point, I am doing work, and my work is getting converted and stored here potential energy, right? So I can say this whatever work done we have spent similar energy which got converted to work. So in other words, say if it is heat energy and I am writing H, so what is H generated, heat generated in this process is VIT, right? Now this is the relationship. If I know V equal to IR, so if I write V equal to IR into I into T, that means I square R into T. Or I can write this is from Ohm's law. I can write V by R, because we know V equal to IR, so I equal to V divided by R. From here I have V by R. So this is V square by R into T. So there are three relationships, three formulas this we can use. H equal to VIT, I square RT, V square by RT. All three are giving same thing. Only thing is depending upon the what parameters are given, we can use them. So we have derived the formula for heat energy. H equal to I square RT. This is called Joule's law of heating. What is called? Joule's law of heating, right? So in case in exam it is coming, what is Joule's law of heating? We can say as per Joule's law of heating, the heat generated in a conductor is directly proportional to square of the electric current and proportional to the resistance of the conductor, and it depends upon the and directly proportional to the time. If flowing for longer time, more heat will be generated. If flowing for shorter time, less heat will be generated. Now let us see which type of connection is done in our house, building, office, or basically practical use. So we had two types of connection, series connection and parallel connection. Suppose if I have and each appliance has resistance. Say for example, fan will have some resistance. This is fan. This resistance is given by fan. So R fan, refrigerator. This is given by refrigerator, by washing machine. Like this I have shown. Now suppose I switched off fan. That means current is not flowing in the fan. When current is not flowing in fan, then the current which was flowing here is stopped. There is no connection. That means everything will be switched off, right? If one of the device goes bad or switched off, everything will be switched off. So it is not the practical connection. One more problem is, when everything is switched on, each one will have different voltage, which is V equal to I into R fan, V2 equal to I into R refrigerator, V equal to I into R washing machine. So voltage is going to be different, but all these appliances are designed for a specific voltage. So this is not a practical connection in house or connecting multiple things. But let me see the case. If this is fan, R fan, and this is R refrigerator, and then it is R washing machine. So if current is coming here and all are switched on, then some current will flow here, some current will flow here, and voltage will be same. So all appliances will be working properly, right? Now if I switch off this fan, so current is not flowing here, but it's okay, still current is flowing in the refrigerator and washing machine. That is what we want at home. If I switch off my TV only should be switched off, not the fan and refrigerator. One more important thing is, what is practical unit of electric energy? If we have to make electric energy, say joule. Joule is very small unit. Joule is very small unit. It's not practical. So the practical unit which we use is called kilowatt hour, right? So when we deal with joule, we deal with watts and seconds. Here we are talking about kilowatts and hours. If I have to convert 1 kilowatt hour is equal to how many joules, then let me convert this kilowatt to watts. Kilo means 1000, so 1000 watts into, and hour will be converted to seconds. This is 3600 seconds. So this will become 1, 2, 3, 4, 5. 36 into 10 raised to power 5 watt second. What is watt second? Watt second is joule. So, or I can write it 3.6 into 10 raised to power 6 joule. This is the relationship. There is one more name for kilowatt hour, and which is more practical. This is called unit. This is called unit. Not that unit of electricity, unit of current. The name itself is unit. When you get the electricity bill, it will be written there how many units you consumed in particular month. Say for example 20 units, 50 units, 100 units, 500 units, right? When you say 1 unit, that means 1 kilowatt hour. Now let us see one example. In this question, it is given an electric bulb is connected to 220 volt generator. That means potential difference is 220 volt. The current is 0.5 ampere in the circuit. What is the power of the bulb? So see, we know energy given was H equal to V into I into T, and what is the power? Power equal to rate of work done, and this was equal to even work. So W by T, which will come, or H by T, here it will be V I T divided by T equal to VI. So power equal to VI. So always remember, if you have energy divided by T, you will get the power. Power is nothing but rate of work done. Rate of work done. In 1 second, how much work we have done, right? So now here power equal to V into I. What is V? 220 volt. And what is I? I is 0.5 ampere. This will come half of this, 110 watts. This is the power. Now this is the question: how many 176 resistors should be connected in parallel to carry 5 ampere on a 220 volt line? So V is given 220 volt, I is given 5 ampere. So from here, this relationship I can find what is R. So V equal to IR. What is this? What is this? This is Ohm's law. So 220 equal to 5 into R. R is 220 divided by 5. 5 4s are 20 and 5 4s are equal to 44 ohm, right? If you remember, I said that if same value we are connecting in parallel, an n number, then what is the total resistance? Rp equal to 176 divided by n. Suppose here we have connected, it is looking like H, n numbers, right? If we have connected n numbers, then this is the value of this circuit, total equivalent resistance. We don't know how many resistors are connected, but we know total should be 44 ohm. So I will write, so that means 44 is known, 176 divided by n. Cross multiplication, 44n equal to 176, n equal to 176 divided by 44 equal to 4. So that means 4 numbers. If we connect 4 resistors in parallel, we will get 44 ohm resistance, and then current flowing will be 5 amperes. I will repeat. Voltage is known, current is known, we can find the resistance. Now we know all are same, and when all are same, it is 176 or whatever resistance divided by n, and this value should be equal to this resistance. And so I am keeping this 44 equal to 176 by n, and from here we can calculate the value n. So we will take one more numerical. So compare the power used in 2 ohm resistors. Remember, 2 ohm resistors only in each of the following circuit. In first, we have 6 volt battery in series with 1 and 2 ohm resistors. So let me make this circuit. So there is a 6 volt battery in series with, so everything is in series, 1 ohm and 2 ohm, right? This is 1. And second is a 4 volt battery in parallel with 12 and 2 ohm. So 12 ohm and 2 ohm resistors in parallel with 4 volt battery. This is the second part of the question. Now we need to find what is the power in 2 ohm resistors. So let us see here how much power is there. Now my target is this resistor. So if I know how much current is flowing in this, I can find I square R, and that will be the power, right? Now, so what will be, how to find the current? If I have to find current here, so as per Ohm's law, V equal to IR and I equal to V divided by R. I know what is the voltage V, 6 volt, but I don't know the total resistance because these are in series. So total resistance is going to be 1 plus 2, 3 ohm. So I can write I equal to V6 divided by total resistance 1 plus 2, which is 6 divided by 3 equal to 2 ampere. So I know the current, I know the resistor. Which resistor? Don't take the combination because same current is flowing here 2 ampere, same is flowing here 2 ampere. So I am worried about only this that is asked. So total power P equal to I square R. I square 2 square, which resistor? 2 ohm. So this will become 2 raised to power 3 and 8 powers of watt. Now in this case also, let me see what can be done. Now one of the option is I can find this current. I will find the total resistance, then current, and then see how much current is flowing. The another option is we already know in the parallel circuit resistance will be, in the parallel circuit voltage will be same across the all the resistors, whatever is connected in parallel. So that means 4 volt here for 12 ohm and 4 volt here. So this is equivalent to, there is a 4 volt. So I need not to worry about other things. I know there is a 4 volt across this. So as per Ohm's law, V equal to I into R, and I know I am worried about only 2 ohm resistor. So here voltage is 4, and that is the case for 12 also. So voltage will be, or potential difference will be same in parallel circuit. And I into R, right? R is also known 2. So 4 divided by R, which is 2I, right? So here also I is coming 2 ampere. Okay, wow. So I'm getting again same answer. Now, so here how much current is flowing? 2 ampere, and again same power equal to I square R, which is 2 square into 2 equal to 8 watts. Now in the last I will take example of, say there is a resistor or conductor which is having length L and cross section area A, and it has a resistance, say for example 10 ohm. What I did, I cut it in the half. Right? So it has become L by 2. Now what will be the resistance of this portion and this portion? How to calculate? Suppose earlier resistance of this wire is R. We know R equal to rho L by A, and I am saying this wire is cut into half. That means I am not changing the material. That means rho is fixed. Rho is not changing. So say suppose R equal to rho L by A. L and A. This is equation 1. In second case, what I have done, say suppose new resistance is R1. Rho is not changing, L has changed to L by 2, and A is also not changing, cross section area. Thickness is not changing, only length is cut into half. If I take the ratio R divided by R1, then R L by A, and what I will do when I have to divide, I will inverse and multiply. So I am doing A divided by rho L by 2. A cancel, L cancel, rho cancel, and then 2 will go up. So R equal to R1 into 2. R1 equal to R divided by 2. That means new resistance, which is R1, will be half of the first one. So in exam question may come like this: what will happen if length is cut into half? In that case we have to say it, prove it, show it like this, and say it will become half. Now suppose the question is twisted and it is said length remains same and diameter is doubled. So now let us see, if in the first case length is unchanged, only diameter is doubled, what will happen? So it was rho L by A, and this is the relationship 1. Now I am doing new resistance is R1 when diameter is doubled. Now A is cross sectional area, which is pi R square. That means I can write pi R can be written D by 2. D is the diameter square, right? So this will become pi D square by 4. So if I write this relationship in terms of diameter, because diameter is given, this will become pi D square by 4 or rho 4L by pi D square. This is the relationship 1. Now in second case, what will happen? Rho is same, material is not changing, length is not changing, everything is same, only thing is D is doubled. So D has become 2D, rest all is same. So it will become rho 4L by this will become 4 pi D square. This is cancelled. Second R, let me take the ratio of these two. R divided by R1 equal to, again same thing, rho 4L by pi D square. I will do inverse and multiplication. So pi D square will go up and rho by L will be here. Rho L cancelled, pi D square cancelled, remaining is 4. So R by R1 equal to 4. That means R equal to 4R1. earlier 4, initial will be 4 times of new one, or you can say R1 equal to R by 4. So new resistance will be 1/4. Now this here is a linear relationship. If it is doubled, this also will be doubled. This is half, this also will be half. But this cross section is related to radius or diameter. It's a proportional to square of that. That's why if we are doing double 2, it is increasing by 4, or it is reducing by 4. If you do 3 times, it will reduce by 9 in terms of square. So this was the electricity chapter, and I hope this will be useful and you will be able to do revision of this chapter very quickly. Thanks for watching my channel, and don't forget to subscribe it. Once again, thanks a lot.